operations on matrices. Addition, difference, multiplication. Matrix addition, matrix difference, and multiplication. Addition, difference, simple it is, not so tough. It's very easy to understand. Multiplication is also easy, but the thing is that you should be a bit careful while solving, because you may in hurry commit some silly mistake which may lead to loss of mark. So we'll see how to avoid this. Okay, first we'll learn addition and difference. First, for addition, looking at the definition, don't get scared. Okay, no one will ask you the definition, but you should know some terms in definition. Okay, in general, if A equal to Aij, B equal to Bij are two matrices of same order matrix, okay, then the sum of the two matrices A and B is defined as Cij m by n, where Cij equal to Aij plus Bij for all possible values of I and j. It's nothing, I'll relate it. Okay, when I compare, we'll understand. Matrix A, matrix B, order is same, right? 2 by 3, 2 by 3. Okay. Sum of two matrices A and B is defined as C. C is nothing. When you solve this, the resultant matrix you get is C. Okay, is of the same order, that is m by n, where Cij equal to Aij plus Bij. This is nothing. Corresponding elements you'll be adding. That is this element A11 you'll be adding with B11, right? So what you will get? C11. Got it? Fine. Okay, so I'll proceed. First, we have this question example from your textbook. Okay. First, see, please, when you write the solution, write this given matrix A and matrix B. After that, the first thing you have to write is matrix A and B are of same order, 2 by 3. Hence, A plus B is defined. Got it? It's up to you if you want to write the addition of A and B is defined, no issues. But I prefer you all to write, therefore A plus B is defined. Okay. So how do you write A plus B equal to? You write the, directly write root 3 plus 2, 1 minus 1 plus root 5, then minus 1 plus 1. Don't get confused, they have just arranged and written. Okay, they have written the positive number first and then the negative number. So you need not get confused what and how, like what happened to this negative one and how come this became negative. It's not like that. They have written this positive number first and then they have written this negative number. Okay, so 1 minus 1 it is. Now we'll go for second row. 2 plus minus is minus, so 2 minus 2, 3 plus 3, then 0 plus half. So when you solve, you get in this way. Okay, this is the matrix. Here what they are saying is, when you're adding, it's very important that the order of that two matrix, whichever matrix you're adding, the order should be always same. If it's not same, then you can write what A plus B is not defined. Is it clear? So see that you have to note that when you add two matrices, order should be same. What you are looking here. Fine, we'll move. Here are some properties of addition of matrices. Okay, so commutative law, that is A plus B equal to B plus A. When you add two matrices A plus B and B plus B, you get the same, it's equal. Associative law, same, A plus B plus C equal to A plus B plus C. Existence of additive identity, it is nothing. When you add a zero matrix with your existing matrix, you get your matrix itself. Is it clear? You remember 1 plus 0 is 1 itself. That's all. So it's nothing other than that. And okay, and 0 plus 1 is 1 itself. Existence of additive inverse is nothing. You remember, if I have a number 2, the additive inverse is negative 2, and when I solve this, I get 0. So same thing. So if I have a matrix A, the additive inverse of the matrix A is nothing, negative A. That is, all the elements of A will become negative, and when you solve this 2, what will happen? You'll get 0 matrix. Is it clear? Okay, so minus A plus A equal to 0. Next we go for difference. Okay, if A equal to Aij, B equal to Bij are two matrices of same order, same the condition we had for addition, here also it is applicable. Order should be same. Say m by n, then differences A minus B is defined as in the previous section you have seen C equal to, here they have said D. It's not like even you can write C, no problem, but here they have written D because it's different. So D equal to Dij, where Dij equal to Aij minus Bij. So I don't think I need to explain you why this is Dij equal to Aij plus minus Bij. Okay, for all I value of I and j. In other words, D equal to A minus B equal to A plus minus 1b. Nothing. What they are doing is they are putting this plus here, and that negative 1, that is the negative, they are multiplying inside the matrix. It's up to you if you want to follow this, okay, or follow this. It's better you go for this one. If you go for this one, there are chances for you to commit some silly mistakes. Okay, it's better directly you subtracted. Okay, that is sum of, this is only to show that the sum of the matrix of A and the matrix minus B, that is defined, they want to say. It's up to you, but it is like if they ask you, you should know such a thing is existing. Okay, I'm not going for example, I'll just move. Multiplication of matrix by a scalar. Okay, what is a scalar? You have learnt in physics, right? But scalar quantity has only magnitude and vector quantity has what? Direction as well as magnitude. But here we'll stick to, like, we'll limit it. That magnitude we are seeing, right? So here it means a numerical value. Obviously magnitude is nothing else, it's a numeric value. So this numerical value can be any number. Is it clear? Can be any number. It can be of decimal, it can be a negative number, it can be a positive number like -2, it can be 2.5. Okay, so what is a scalar? Okay, it's nothing, it means what? A numeric value. Got it? I guess you all understood. When you see the term scalar, don't get scared. What is a scalar and all, from physics coming to maths. Okay, already you're learning physics, so you need not be shocked or surprised about the term scalar. Okay, I'll directly move on to the properties. Okay, here they have taken nothing, a simple k they have taken. K is a scalar value, nothing, a value. If I say 2 is a scalar value. Okay, k a plus b, that ka plus kb. Next, k1 plus k2 a equal to k1 a plus k2a. k1 k2a equal to k1 k2a, k2 k1a. Anyhow you can multiply, it depends upon like how you need the scalar value. Negative k equal to negative within bracket k within bracket negative a. Okay, when you solve problems you'll understand more. Okay, here we have a simple problem. We'll see how it works. Okay, so here goes. Okay, here we have matrix A, matrix B. Obviously we are addition is there, so check the order is same, so we can proceed. So it is defined, right? Then find matrix X such that 2A plus 3X equal to 5B. Okay, next, now what we are supposed to find? 3X, right? Sorry, X we are supposed to find. Matrix X they have asked us to find. So 2A, so what we have to separate this 2A from LHS. So what do we do is we'll put in the RHS. So what do you get is 3x equal to timing, will skip this step. Okay, okay, so 3x equal to 5b minus 2a. Is it clear? So here 3 is there, it's a scalar value. So when it goes this side, it will be dividing, that is, it will become 1 by 3. That is what we got here. Okay. So same way, 5b means nothing, you will multiplying 5 with each and every element of the matrix B. So when you multiply, what did you get? 10, 20, 5 into 5 is 25, negative 25, and 5 into 1 is 5, 5 into 2 is 10, 5 into 0 is, sorry, 5 into negative 2 is negative 10. Next, 2a. So the scalar value you have to multiply with matrix A. So what did they do? They kept a plus here and they've used the negative 2 and they've multiplied. So negative 2 into 8, negative 16, negative 2 into 0, 0, negative 2 into 4, negative 8, negative 2 into negative 2 is 4, negative, negative, positive, negative 2 into 3 is negative 6, negative 2 into 6 is negative 12. So here we complete. Okay, so what next we'll be solving? 10 plus negative 16, that is 10 minus 16, minus 10 plus 0. So corresponding elements we are adding. Okay, 20 minus 8, 10 plus 4, negative 25 plus negative 6, 5 minus 12. When you solve, 10 minus 16 minus 6, this one we get negative 10, this is negative 12, 14, here we have negative 31, negative 7, right? Okay, so now 1 by 3. So each and every element you'll be multiplying by 1 by 3, or in other words you can say you'll be dividing each and every element by 3. So here we get 2, negative 10 by 3, 4, that is 12 by 3 is 4, 14 by 3, negative 31 by 3, negative 7 by 3. Completed. Product, that is multiplication of matrices. It's very simple. Don't get panic when you see the definition. I'm not asking you to by heart the definition. We'll just go through, like, should be aware of the terms, right? Okay, so we'll start the definition. The product of two matrices A and B is defined if the number of columns of A is equal to number of columns of number of rows of B. In simple words, if you have a matrix A, order is m by n. What is the order? M by n. Okay. And Bn order is n by p. So what is the order of matrix B? N by p. Okay. What they are saying is number of column of A equal to number of rows in B. This should be equal. Number of column of A should be equal to number of rows in B. You remember CR7? Who is he? Yeah, he's a footballer. Can you name the team he plays? Which country he represents? Portugal. Yes. Okay. I'm not going further in depth because even I don't know about CR7 much. I know he's a Cristiano Ronaldo. That's all. Belongs to which team? Portugal. I mean country. Okay. So this is clear now. Okay, you have to check this in multiplication. Okay. So I guess till here it's okay, your definition. Then the product of the matrices A and B is a matrix C of order, that is a resultant matrix of order MP. So your resultant matrix, your answer matrix will be of the order what? MP. That is this row and the column of your second matrix. Is it clear? When you solve, you'll understand more. Now I'm not making you all confused what it is, only making you all aware of the terms. Okay. Now what is the order? M by P. To get I comma kth element Cik of matrix C, we take ith row of A and kth column of B, multiply them element wise and take sum of all these products. In other words, in matrix A and matrix B, the ith row of A is and kth column. Okay, if you are taking ith row, and of matrix B we are taking kth column. Okay, I'll explain you, don't worry. So what will happen, the resultant element of the resultant matrix will be, what you'll be doing is you'll be multiplying ith row of A and kth column of B, and each will be adding, also multiplying, adding. I'll tell you how it is. So what do you say, this one equal to summation j equal to 1 to n aij b jk. Let's see how it is. Okay, order what it is, 2 by 2, fine. And here the order is how many rows? 2 row and 3 columns, fine. Order is, here the order is 2 by 2 and 2 by 3. See, always when you multiply, please go for the order first, so that clarity is there. Okay, same, CR is same, right? So that means we can multiply. What will be our resultant matrix order? 2 by 3. Got it? So first you have to write matrix A has 2 columns, which is equal to number of rows of B, hence AB is defined. Okay, so here it is nothing. What did they say here? Ith row, that is first row, first column. You will be multiplying this and you'll be adding, that is multiplying and multiplying, and you'll be adding. Okay, don't go in depth, I'll just move. So here likewise it is done. I'll solve and show, that is better, right? So example 12, find AB if A, this is one matrix. So first we'll write the order of this matrix A is 2 by 2. Okay, order of matrix B is 2 rows and 3 columns. Okay, now we know, see here we have 2 columns and 2 rows, right? So our CR is okay, so our first condition is satisfied, that is, so when we write solution in matrix A has how many? 2 columns, which is equal to number of rows in matrix B, hence AB is defined. Okay, so we can move. So AB, can anyone tell me what will be the resultant matrix order? 2 row and 3 columns, 2 row and 3 column. Okay, typing, I'm not putting square brackets. Okay, what did I say? First row, first column, right? Okay, so 6, 9, we'll put first this number. Okay, 6, 9. In each column, 3 columns, we'll put 6, 9. Okay, now what is the first column? In first column we have 2, 7. So here we have 2, here we have 7. Second column element 6, 9. Okay, third column element 0, 8. So we know that what do we do is multiply and add, right? Multiply, add. It's nothing. First row, first column, then this first row, second column, first row, third column. Same way, we'll go for the second row also in the same way. No need of getting confused what to do and all. So 2, 3. I guess almost you got an idea what to do. 2, 2, 3. Okay, now what you'll do again. What is the first column elements? It is into 2 plus into 7, right? Into 2, sorry, into 6 plus into 9 into 0 plus into 8. Equal to 12 plus 63. Then 36 plus 81. 0 plus 72. So I write directly what 72, no need of 0. 4 plus 21. 12 plus 27. And we have 0 plus 24, right? Okay, so what is the answer? 75. Then yes, 117. Then it's 72. Then 25. It's 39. And this is your resultant matrix of order 2 by 3. So I guess we got the answer. So let's move on. So I guess multiplication is also tough, right? So for multiplication we have a property that is non-commutativity of multiplication of matrices. That is, when you multiply two matrix and if you multiply BA, when you change, that is you make it BA, it won't be equal. That is, multiplication of two matrices is non-commutative. Okay, here we have matrix A and here we have matrix B. So what's the order of this one? 2 by 3, right? That is 2 rows, 3 column. Over here 3 rows and 2 columns. So we have same number of column and rows, so it satisfies our first condition, so we can multiply. So when we first we are supposed to find AB. So after finding AB, what do we get is 0 minus 4 10 3. Okay, next we solve for BA. When we solve for BA, what happens? Just see, minus 10 2 2 1, negative 30 16 2 37, negative 2 negative 2 11. Order also changed, as well as it's not same, right? So it is said like it's not equal, so it is said that AB not equal to BA. That is, multiplication of matrices is non-commutative. Is it clear? Okay, now go for next property. Before that, if we have matrix A and we have matrix B, okay, when you multiply this matrix AB and BA, you're getting equal. What will be the reason? Did you notice it's a diagonal matrix? Because its non-diagonal elements are 0. So when you multiply two diagonal matrices, for that time what multiplication will be commutative, that is multiplication of diagonal matrices of same order. One more thing should keep in mind, it should be of same order. So multiplication of diagonal matrices of same order will be commutative. Don't forget this, okay? Next, zero matrix as a product of two non-zero matrices. It's telling if we have two non-zero matrices, that is matrix A is non-zero. If it is zero matrix, to make it clear, zero matrix means all elements are 0. Here all elements are not 0, only two elements are 0. So this is not zero matrix. So it is a non-zero matrix. Same way it's applicable over here, non-zero. So when you solve this 2, that is when you find the product of A and B, what happens? You're getting a zero matrix. So when you find the product, so it can be, that is when you multiply two non-zero matrices, you may get a zero matrix. Is it clear? We'll go for property of multiplication of matrices. Already we have gone for the two properties, that is non-commutativity of multiplication of matrices, two matrices, and the product of two non-zero matrices can be a zero matrix. And here the other properties are associative law, that is A, B, C equal to A, B, C. So it will be equal, they are saying. Distributive law, A, B plus C equal to AB plus AC. When you solve this, you will get LHS will be equal to RHS. Then AB into C equal to AC plus BC. Here also what it will be equal. Existence of multiplicative identity. Okay, that is when you multiply an identity matrix with a matrix, you get the matrix itself. That is, if it is IA equal to A, then AI is also equal to A. Only you remember, like for every square matrix, that is for the product of the matrix, square matrix and the identity matrix will be the matrix itself, not the identity matrix. The matrix what you're multiplying with that identity matrix. Is it clear?